Alright students, welcome to the next video. This one is about vectors. So we're going to go ahead and do our warm-up, which covers the laws of sine and cosine that we went over in the last video. So number one, use the measures of triangle ABC to find C to the nearest tenth. So we have the angle across from C, and we have two other sides. So because we have two other sides, we don't have any other angles, we have to use, and we're trying to find a side, we have to use the law of cosines. So when we write this out, C is what we're trying to find. That's going to be equal to 8.8 squared plus 20 squared minus 2 times 8.8 times 20 times cosine of their angle, which is 26 degrees. Now, all we have to do before we can plug it into Desmos, or any calculator, is see, well, not really your phone calculators. They don't really want to work for long formulas like this, but if you use Desmos or if you have a TI calculator, there's the ones you can use. So 8.8 squared inside the square root plus 20 squared minus 2 times 8.8 times 20 times cosine of 26. So all of that inside the square root, you don't have to hit anything on Desmos. If you're on a TI calculator, you hit enter, have it solve it, and our C comes out to be 12.7. For number two, we need to use the measures of triangle ABC to find the measure of angle B to the nearest degree. So same triangle we had earlier, we're still going to use it. And now we're trying to find another angle. So because we're looking for an angle now, we can use our law of sine. So sine of 26, since that's the only angle we do know, we then can use what we have from our last problem, the C we just found, over, so the sine of 26 over our 12.7. Now, typically whenever I'm using something I know I just rounded on, I don't like to use the rounded version. I really would prefer to keep the one from the calculator. So when I'm actually calculating this, I will do that. So when you see the answer, if you plug it in with the exact 12.7, you might be off a hair on the decimal, but should be pretty close still. So that's going to be equal to sine of B over 8.8. And we're going to cross, actually we're not going to cross multiply, sorry. All we have to do is multiply by 8.8 on both sides. Cancel on the right side, and we're left with sine of B being equal to 8.8 sine of 26 over 12.7. Now, because again we're trying to find an angle, we're going to use our inverse sine. So sine inverse, or arc sine in Desmos, 8.8 sine of 26 over 12.7. That's equal to B. And again, if you enter it into Desmos exactly how I have it, or a TI calculator for that matter, it's going to follow order of operations, so you can type it in exactly how I have it there. It'll work out. It won't show the fraction as a fraction entirely like Desmos will, but again, it follows order of operations. So unless you are worried about that, then you can put the entire top in parentheses. In this case, you don't have to do that because there's no addition in there. So B comes out to be, it says to round to the nearest degree, so when you round, it's 18 degrees. So there's our B. Alright, so let's move on to the notes. Today we're looking at vectors. So we have some vector as one of our vocab words for the day. Magnitude, direction, resultant. If you're in physics, hopefully you've learned some of this stuff already. If not, and you are in physics, I'm not very happy with your physics teachers. Maybe it's just something you're going to get to this semester. I can't imagine that. When I taught physics, I used to teach physics in Bryan College Station. That was one of the first things we learned. But if not, I guess that's all right. Parallelogram method, triangle method, standard position, and then component form. Those are our 8 vocab words for the day that we hopefully have already defined and looked at, so we know what they mean. But we'll see them again here. So our first example, example 1A for that matter, wants us to use a ruler and protractor. Kind of hard to do whenever you're on an iPad like I am. So I'm going to just draw lines that I know are pretty close to that. So it's going to be kind of off a little bit, I'm sure, because I'm definitely not perfect, that's for sure. So I'm going to make that is definitely crooked. So I'm going to make a coordinate system here. So there's our coordinate system. Now, whenever it says, occasionally it'll say, 24 degrees west of north like it does here. Sometimes it'll say something like 114 degrees without any direction to it. It's still telling you a direction. So typically whenever you're talking about direction like that, it's going to start at 0 degrees. Sorry, I'm the wrong writing thing here. So this is 0 degrees here off the east. The east is 0 degrees. And then north is 90 degrees. And when you get into pre-cal, this is exactly what you're going to be doing. So this is 180 degrees because it's flat, right? And then down here's our 270. And technically, if you want to do 360, it'd be where 0 is again. So it goes around the circle here counterclockwise. In this case, we are just doing 24 degrees west of north. So we don't really need all of this information. So I'm going to delete that arrow actually. But sometimes you will have that happen, all right? So just be aware of that. And some of the answers I'm going to give you both to let you know that we're talking about this degree, or this angle south of west, or this angle total, okay? So 1 inch. So the nice thing about this app that I use for writing all this stuff is I can make an arrow, which vectors, when drawn on anything, should be arrows. So 1 inch is, we're going to say 80 meters here. So 1 inch is 80 meters. That means that at 24 degrees, that's going to be about over here somewhere. See the red point that I just made. So I'm going to draw an arrow that direction, and I'm going to say that whatever length I make the arrow is to scale 80 meters. So it says to make a scale, and again, because I do not have the ability to put a ruler on here, as nice as that would be, maybe I need to contact the creators and say they need to do that. So that's going to be our vector S, so just label it as S, and to label a vector, you can kind of see that on the top there. It does have a little arrow on the top of it to label it as vector S. So this is our 24 degree angle here. But 24 degrees west of north, when you add that to 90, because that'd be the entire length, right? Would be, or the entire rotation, would be the 114 degrees I was talking about earlier. So this is 114 degrees. This is 20, ooh, that's a bad look at 24 degrees here. Not much better now, but anyway, so there we go, 24 degrees. We're going to say that this line is, on my iPad, a little over an inch, but when you project it on the screen, it's going to be a lot bigger than an inch. So there we go. All right, so there's as close to as good as I can get it without really having a protractor or a ruler. So number 1, part B, same idea. So let me draw our unit, or our coordinate system. little crooked there, but that's all right. So now we see 165 degrees to the horizontal. So that would mean, again, we're going around the circle this way. So 65 degrees would be from our 0, or east, 165 degrees. So we're going to go up to the 90 up top. We're going to go past all that. So it's going to go around to some number over here, 165, which is about here. So again, I'm going to draw my arrow to it. There's our vector, 165 degrees. Using our circle. So there's the 165. So when it says to the horizontal, that's what it's meaning. So it's almost to the horizontal, but it's not quite there. 180 would be our horizontal, right? So there we go. Again, kind of hard to do without a vector, or a vector, without a protractor and ruler, but you get the general idea. So here we have some options, right? So using a ruler and protractor, we want to draw a vector to represent vector n equal to 90 feet per second, because I don't know if you guys know what vectors are as far as numerically speaking, but distance, velocity, acceleration, force, all of these things are types of vectors. They all have magnitude, they all have direction. That's why those are vocab words. Vectors have to have those two things, magnitude and direction. So our magnitude here would be the 90 feet per second. The direction would be the 25 degrees east of north. So those are the two things we know about the vectors. So when you're driving your car, your speedometer is telling you the speed you're going. That's a scalar, which means it's just a number, or just a magnitude. And if you had a compass in your car, it's not a lot of new cars that have that stuff, you could find out your direction too. So that means you would actually, I mean, not down to the degree, but you could find your direction in general, and that would give you your vector. Then you could say you're going 60 miles an hour at a direction of northwest. So that'd be about 45 degrees in between north and west. So here we got 25 degrees east of north, so that's going to be to the right of north. That's our 25 degree angle. So the only one that really shows that is B. I think C's trying to, but there's definitely an error going on there. And 90 feet per second, again, we don't really have a scale, so I mean, we are given a scale. 1 centimeter should be 50 feet per second. Now on the computer screen I have, when I measured that with my ruler, C is actually pretty close to being the right length. My only worry is the angle, and actually it's off. That one's off pretty bad too, because if you notice here, the arrow is pointing down for one, and the point doesn't go in the origin where it should. So all the more reason why C is wrong, and the other two don't point the right direction. D is going 25 degrees west of north, and A is going 25 degrees north of east, so it's backwards. So B is our answer. So here are two methods that we are going to look at today to add vectors. So the first one here, and when you add two vectors together, the sum, or the answer is the resultant vector. So it's another vector. You add two vectors together, you get a vector. So the parallelogram method is to translate the second vector so that the tail of it is touching the tail of vector A. And then you just make a parallelogram out of that. So you draw two dotted lines that are parallelogram to the two vectors you have, and then you draw your resultant vector will be the line that connects the tips of, or the tails of your two vectors to the connection of the two dotted lines. The triangle method, and when I taught physics, this is also known as the head to tail method. It works that way too. So you translate B so that the tail of B touches the tip or the head of A, and then you draw the resultant vector from the tail of A to the head or tip of B. So that's why it's head to tail or tail to head. Either way, it works. Now, for some reason, we don't have any examples of adding vectors. We have some examples, pardon me, of subtracting vectors. So make sure you write all these down. Pause it here if you need to and write it all down. That way you know what you're looking at when you actually have to add two vectors together. Subtraction works very similar though. And basically, instead of doing the parallelogram method the way it is, instead of the two tails touching, the two heads would touch, and then you would go from the connection of the heads to the connection, or to the dotted line connection again for the parallelogram method. For the triangle method, he would again put the heads together instead of head and tail together, and then connect the way you do in the triangle method to add. So let's look at our first example. We're going to copy these two vectors. Now I can do that very easily on this iPad. Thankfully I don't have to measure anything. I can just make two arrows that are the same length and move them around. So this is actually going to be really easy. Just need to make some adjustments here and make sure that we are able to do a resultant vector as well. Alright, so let me sketch out these two here. So B, that's not quite there yet. It's kind of hard to do. Ooh. You can't really see what you're tracing, right? Kind of defeats the purpose of tracing if you can't trace what you're trying to trace. Alright, so there's our two. Now I can select them and move it around. So there's my B. Sorry, having some technical difficulty. There we go. And there's my A vector. I don't know why my B vector is so light now, though. Oh, there we go, because I had A vector selected. Sorry. All right, so we're going to subtract here. So what we need to do sorry, hitting the wrong buttons here. So we're going to first start off with our A vector. So I'm just going to do this underneath here. So there's our A vector right there, going up still, and it's subtracting our B. So this is going to be using the parallelogram method first, and then off to the right I'll use the triangle method. So now what we're going to do is take our B vector and we're going to move it to where the heads are touching, wrong method, where this head is touching the tail for the parallelogram method. So there's our two vectors together. That's not our answer just yet, so hold on with me here. Okay, hold on. I have to undo some stuff. It's my first time doing this. So, alright, so now I'm going to duplicate my vectors because I need them to make a parallelogram. Alright, so now, there we go. So now, again, I'm going to label these so we know what we're looking at. So this is our A vector. Now we're going to take the B vector and put the head of it to the tail of our A vector. So there we go. There's B. Actually, I'm going to move that. And now what we need to do is make it into a parallelogram. So I'm going to move my copies of these vectors to where I can make a parallelogram. So there's our A vector copied, and our B vector copied will go on the top here. So there we go. And now to get our solution, all we have to do is connect where our original two connect together to where the new two connect together. So that purple line there is our solution. That is our resultant vector. Okay, so now for the triangle method. Probably should have copied our vectors again for this, but that's okay. I'll remake them. So there's my A vector again. And my B vector again. Now I don't have to have copies of them to do the triangle method because I only need 3 sides, so our third side will be our resultant side. So for the triangle method, you start with your first vector again. And then instead of doing head to tail like it says to in the triangle method, what we're going to do is put our heads together like that. And then you're going to again start from the bottom of the first vector and go to the bottom of the last vector. So there's our resultant again. Looks pretty much identical to what we had before using the parallelogram method, which is good because it should be identical. It's the same 2 vectors we added together, or subtracted here. So there we go. So this is the triangle method and the parallelogram method. Okay, we got to get moving now. Okay, so here's an example here of subtraction again. So if we look here, A is going down and B is going to the right, right? But we're going to subtract B, so that means B needs to go to the left instead. So we're going to go down and to the left, and the only one doing that is A. Okay, now component form. We've seen vectors before, or we should have anyway. If you didn't, either if you're in my class, you weren't paying attention, and if you're in Ween's class, hopefully it just is that you weren't paying attention. So vectors, remember back to when we were doing translations of points or anything. When we translated something, we had to have a translation vector. So now we have a line, and we need to find how it's changing, right? So to find that, what you're going to do is, here's your vector, right? You're going to take your x from your second vector and subtract your first one. And the same for the y's. So what that means is, for this one here, now your 2's are going to be B here. It goes from A to B. So we're going to go -5 minus a -1. So if you don't have my class, you notice I just made it a plus, right? But it's a minus a negative, which becomes a plus, okay? So then we got -1 minus -4. So now we can simplify this. -5 plus 1 is negative 4, and negative 1 plus 4 is 3. And there's our answer. Okay, we're going to do the same thing for the next one. Different drawing, same idea. But we got some options here. So if we look at where we're going, or where we are, so it's, again, remember x2 minus x1 and y2 minus y1. Should sound kind of familiar, like it's slope or something, you know, or maybe the distance formula. Anyway, hint, hint, we will be using the distance formula in a minute. So we have our top vector is going to be 3 minus our bottom, or not vector, top point, 3 minus 1 for our x's, and 6 minus 2 for our y values. So 3 minus 1 is 2, 6 minus 2 is 4. Our point should be at 2, 4, which is B. Okay, so now we're looking at magnitude and direction. So remember when I said we were going to use the distance formula about, say, 10, 15 seconds ago? Yeah, here we go. Now we're going to use the distance formula. It's a bit different than your normal distance formula, though, okay? So instead of having all that stuff inside, we got a square and all that stuff. You still have to square, but basically this is what's happening. We have a vector that we know is 7, negative 5, right? So we know it's going up 7, and it's negative 5, so it's going to go to the left 5. So now our resultant, or the actual vector we're talking about, is this purple one in between these two, right? See a triangle? So what we're going to use is basically Pythagorean theorem, really, not really distance formula. So we know that Pythagorean theorem to get that last bit of our triangle, because this is a right triangle. When you have vectors, you're looking at the x value, so left or right, and then your y value up or down, which just made me realize I wrote this out wrong. Let me erase this. Sorry. I'm not going to redo the entire video just because I just messed up. Let me redo that though. So 7 is our x. That means we're going to the right 7. And 5 is our y. It means we're going down 5. So there's our resultant, or what we actually have, right? So all we need to do now you see our triangle, right? It's a right triangle because we're going to the right 7, down 5. So all we have to do is go r is equal to the square root, because really in Pythagorean theorem, right, it's a squared plus b squared equal to c squared. In this case, our r is our c. So that's what we're looking to find. So you're going to square root both sides. So a squared here would be our 7 squared plus b squared, which is 5 squared. So now we just need to simplify or solve this. So our 7 squared is 49, and 5 squared is 25. And r, really, if you had used the original triangle I had, you'd get the same answer out, because we'd still be using 5 and 7, but that's all right. So when we get that, it's the square root of 74, and that does not break down, so we can leave it as that. So that's our magnitude. And now we need to find our direction. So now, direction means, just like we had earlier, right, when we were looking at our coordinate system, right? So here's our coordinate system. So our angle is this angle here, right? But we can't really find that without a lot of work. Or really not a lot of work, but what we need to find first is this purple angle here. So we're going to use tangent because we have our legs. Granted, we do have our our hypotenuse now, so we just got it, but that's not what we're trying to find. So, tangent of our direction, so theta we'll call it, that's what's inside there, the purple angle, is going to be opposite, so 5/7. So that means we have to do inverse tangent of 5/7. That's going to be our theta, or our direction, which is 35.5 degrees. Now, at this point, we can describe it however we want to. So we can leave it as, or we can, if we leave it as this, we need to describe it as it's going to be south of east, right? So south of east. Technically, you could shorten this up to, you can do S of E. I'm good with that too. Or we can subtract this number from 360, because we know a full circle is 360, and that will give us the entire distance, or the angle around the circle to get to this point. So, oops, sorry, still having technical difficulties. So going all the way around, this is going to get you a theta of, or 324.5 degrees. And when you do that, you don't have to give any description of your direction. So either of these will work. Any normal human being would take either of these two as your answer. I kind of prefer the bottom one, just because whenever you get into pre-cal, that's how things are going to go in there. If you were to move on and take college physics classes, that's also how you would describe it. No self-respecting physics professor would have you write out the south of east stuff. That's weird. So, all right, next problem. So here again, we have our vector at -4, -4. So, nice thing here is I can't draw it the right. I keep pausing this on accident. So, sorry if the sound is a little weird. So, what we're going to do here, the nice thing, they're both -4, so I can't really mess up on our drawing like I have been. So, for one, our x is going to go negative, so -4. And then the y will also go down -4. And our resultant will be going down this direction. So, again, we would have, for our direction when we get there, is it going to be all the way around here? Or you can say it's going to be south of west. But really, because they're both the same, you can actually even describe it a different way too. I'll explain that in a second. So we know that this is 4, this is 4. So what do we know about right triangles that have the same sides? It's a special right triangle, right? This is a 45-45 triangle. So already we know that this angle here is 45, this angle here is 45, and because we know it's a 45-45 triangle, we also know that this is going to be 4 times the square root of 2. So now we just need to solve what 4 times square root of 2 is. Super easy, right? So 4 square root of 2 is about 5.7. And because we know it's a 45-degree angle there, if you look at all the answers, 45 degrees is there, right? But again, if you are going to give that angle like it is here, you have to describe it too. There's no description here. 45 degrees isn't there. 45 degrees is up there where the red line is. That's not where we are. That's the opposite direction. Like entirely opposite direction. So A and B can't be our answers. So C has to be it because it's the only one with the 5.7. And you add 180 to that 45 and you get the 225. So let me write that out. 45 plus 180, because again, this is 180 degrees, is 225. So there's our answers, magnitude and direction. So C is our answer. All right, so vector operations. So this is kind of just a general idea about vectors. So you can add, you can subtract, you can multiply by a scalar, so just some number. So you can double it, make it longer. Direction is going to change with that. If you add or subtract, your direction could change. So let's go, hopefully you have written this down. If not, pause it, write it down. Let's move on. We're going to use these now. So we got a few examples here of using our vector operations. So here we are adding the two together. So again, if you have your x and you have y and z for when we use it in a minute, you're going to do 3 problems with all these same vectors. So we're going to add x plus y. So that means we're going to go, I don't know why I'm using purple anymore. I'm going to go x plus y. So really this is kind of confusing, but the xx and the yx, and then the xy plus the yy. So the reason I did that, to give the subscripts, is that the x value for the x vector, and then the y value, or the x value for the y vector, the y value for the x vector, and the y value for the y vector. A little confusing, but basically what we're going to do is go -1 plus 3 and 4 plus 1. So when we add those two together, we get a vector of 2, sorry. Can't read my own handwriting on my paper that I wrote all this on. 2, 4. There we go. Okay, next one. Here we're subtracting. So we got z minus x. So I'm not going to write it out like I did in the last one. It was a little weird. But, so if we take our z value, -2, for the x value for the z vector, then the x value for the x vector is -1. So we subtract -1. Then we have -4 is the y value for the z vector, and we subtract 4, which is the y value for the x vector. So when we combine these together here, or not subtract, we're adding. No, we are subtracting, sorry. Brain fart. Alright, so -2 plus 1 gets us a -1, and -4 minus 4 is not 0, people. It makes it more negative. It's -8. You take away more from a negative, you got to make it more negative. Alright, so our next problem. So here we got -1, -8 is our vector. Okay, our next one here is multiplying now. So 2 times y, so we're going to do that first. So 2y is going to be 2 times 3, and then 2 times 1. And multiply both inside parts of the vector. So that means that 2y is equal to 6, 2. Now we're going to add that to z. So 2y plus z is going to be 6 plus our -2 from the z vector, and 2 plus -4 also from the z vector. So we end up with our answer being 6 plus a -2 is the same as 6 minus 2, that's 4, and 2 plus a -4 is 2 minus 4, which which gets us -2. There's our answer. Alright, so this one here, same idea, but now it's multiple choice. So we have our two vectors, and we want to do all this manipulation too. So we're going to multiply 3 times the a vector. So that's 3 times 2, and 3 times -1. So that is equal to 6 and -3. And then we're going to add that, or subtract the b vector, sorry. So 3a minus b is equal to 6 minus 5, and -3 minus a -3. So our answer comes out to be 6 minus 5 is 1, and -3 plus 3 is 0. So 0, or 1, 0 is our answer, and that is D. Alright, so now we got our last example before the exit ticket. This one here, we suppose a person is canoeing due east across a river at 4 miles per hour. So due east is off to the right, right? And they are going at 4 miles per hour. The river is flowing south at 3 miles an hour. Obviously not drawn to scale. We need to find the magnitude, the resultant speed and direction of the canoe. So magnitude and direction of this purple vector. So again, magnitude, remember, is just going to be your R here. R is equal to the square root of 4 squared plus 3 squared. So 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. So the magnitude here is 5 miles per hour. And our direction is going to be the inverse tangent of, trying to find this angle here, of 3/4. So our theta comes out to be 36.9. However, that's great, but we can say that, but we have to describe it, right? So this is going to be south of east, or we can subtract this from 360 again, and this gets us 323. So there's our two answers, our magnitude and our direction. Your exit ticket is exactly like that. You got another problem just the same way. So do the exact same thing we just did. Just change the numbers to 7 and 4, and that's it. You're good. All right? And we will see you next time. I'm going to try to get some videos done for some previous lessons for Miss Ween's class and for my class if you guys want to review. I'll be getting those things done and posted up in the coming days. All right? So thanks for watching.